So what are the various physical properties of fluids? Some of the important physical properties of fluids are density, specific weight, vapor pressure, and viscosity. There are other physical properties, but let us discuss the first four properties in detail. So what is density of a fluid? Density of a fluid is defined as mass by volume. That is M by V. So density of water, is commonly used fluid, is 1000 kilogram per meter cube. And what is specific volume? That is the volume of the fluid divided by mass. That is the reciprocal of density. That is equal to 1 by rho. Nu is equal to 1 by rho. So what is specific gravity or relative density? Here we are making a comparison with respect to the density of water. So specific gravity is defined as density of the fluid divided by density of water. That is called specific gravity. So what is specific weight? Specific weight is defined as density of the fluid into acceleration due to gravity. So that is specific weight. So what is vapor pressure and what is cavitation? Both are related to each other. So let us understand what is vapor pressure first. The pressure exerted by its vapor in phase equilibrium with its liquid at a given temperature is called vapor pressure. So you can see in the figure, so there is evaporation taking place. We will discuss about evaporation in detail. So the pressure exerted by this vapor is called vapor pressure. So what is evaporation? Evaporation is a surface phenomenon in which liquid is just converted to vapor. And the pressure exerted by this vapor is called vapor pressure. So there is also an atmosphere at the top of this beaker. And the atmosphere exerts a pressure downward, which is equal to the sum of partial pressures of water vapor and dry air. Because the atmosphere consists of water vapor and oxygen and nitrogen. The water vapor constitutes only very low percentage in the atmosphere. This atmosphere exerts a pressure downward, which causes the vapor or the water vapor to go into the liquid, to get converted to liquid. So there is evaporation occurring at the surface, that is liquid getting converted to vapor and also vapor getting converted to liquid. At equilibrium, the amount of liquid getting converted to vapor will be equal to the amount of vapor getting converted to liquid. At this point, the pressure exerted by the vapor is called vapor pressure. So partial pressure is defined as the pressure of gas or vapor in a mixture with other gases. Okay, so if you take atmosphere, you can see that there will be water vapor, that is of blue color. There will be water vapor and also oxygen molecules, nitrogen molecules, etc. So this atmosphere will exert a pressure downward, which causes some of the vapor to enter into the liquid, getting converted to liquid. So the partial pressure is defined as the pressure of a gas or vapor in a mixture with other gases. You can see this in the atmosphere. There will be water molecules, and these water molecules, the pressure of these water molecules is defined as the partial pressure of water vapor in atmosphere. So let us take an example, that is evaporation of water at 20 degrees Celsius. You can see in the figure the vapor pressure of water at 20 degrees Celsius is 2.34 kilopascal, and the partial pressure of water vapor is 0.34 kilopascal. Therefore, a bucket of water at 20 degrees Celsius left in a room with dry air at 1 atmosphere will continue evaporating until one of the two things happen. The water evaporates away, that is, there is not enough water to establish phase equilibrium in the room, or evaporation stops when the partial pressure of water vapor in the room rises to 2.34 kilopascal, at which point phase equilibrium is established. So you can see in the figure 1 there is evaporation taking place, and in figure 2 you can see that some of the vapor is getting converted to liquid, that is entering into the liquid surface. And in the figure 3 you can see that the phase equilibrium is established, that is vapor pressure will become equal to the partial pressure, that is, so some of the water vapor in the atmosphere is entering into the liquid surface. So amount of liquid getting converted to vapor will be equal to the amount of vapor getting converted to liquid. This happens when the vapor pressure is equal to the partial pressure. So in figure 3, when the phase equilibrium is established, vapor pressure is equal to 2.34 kilopascal and partial pressure is equal to 2.34 kilopascal. In the left hand you can see that in figure 1 the vapor pressure is equal to 2.34 kilopascal and partial pressure is equal to 0.34 kilopascal. In figure 1 there is no phase equilibrium, and in figure 3 there is phase equilibrium. So what is the difference between boiling and evaporation? Both boiling and evaporation, liquid is getting converted to vapor. See, in evaporation, it is a surface phenomenon, whereas in boiling, vapor bubbles form from the bottom. You can see the vapor bubbles here. It forms from the bottom. Boiling occurs when the vapor pressure is greater than atmospheric pressure. This can occur in two ways, either by heating the liquid or by reducing the atmospheric pressure. So we have seen that there is an atmosphere pressure acting on the top of the liquid. So when the vapor pressure is more than the atmospheric pressure, boiling can occur. But evaporation, it is a surface phenomenon. It occurs continuously. So that means there is some liquid getting converted to vapor and some vapor converted to liquid. And the pressure exerted by this vapor is called vapor pressure. We have seen that earlier. And in evaporation, bubbles cannot form since the vapor pressure is less than the atmospheric pressure. So what is cavitation? So once you have understood what is vapor pressure, what is evaporation, and what is boiling, let us see what is cavitation. Cavitation is one of the important things you need to know in fluid mechanics. Cavitation is defined as the process of formation of vapor phase of a liquid when it is subjected to reduced pressures at ambient temperature. So we have seen that water boils when the vapor pressure is greater than the atmospheric pressure. Okay, so that means that can happen in two ways. That is either by supplying heat, heating the liquid, or by reducing the atmospheric temperature or reducing the atmospheric pressure. So you can see that in this figure there is a pressure drop in the middle, that is called the throat region. So when the pressure is dropped, that means when the pressure is lower than the vapor pressure, boiling occurs. So it is not by heating the liquid but by reducing the pressure. So here the pressure, that is the pressure, is taken as the atmospheric pressure. So when the pressure is very low, boiling occurs. And these vapor bubbles get travel to the other regions. You can see that is called cavitation bubbles. And these bubbles expand and these bubbles later collapse, releasing intense energy. And this can harm some of the equipments. So cavitation is defined as the process of boiling in liquid as a result of pressure reduction rather than heat addition. So that is very important because here water boils due to pressure reduction rather than heat addition. So you can see that here the cavitation bubbles. The vapor bubbles called cavitation bubbles, since they form cavities in the liquid, collapse as they are swept away from the low pressure regions, generating highly destructive, extremely high pressure waves. You can see that in the figure, the bubbles continuously expand and finally it collapses, releasing huge energy which can harm the equipments, particularly hydraulic machineries. So, for example, water at 10 degrees Celsius will flash into vapor and foam bubbles at locations. That is, water at 10 degrees Celsius will flash into vapor and foam bubbles at locations such as the tip regions of impellers or section side of pump, where the pressure drops below 1.23 kilopascal. So you can see that because of cavitation, the impellers are getting damaged. Here the water is boiling at 10 degrees Celsius because of the pressure reduction. Because the pressure here gets dropped to 1.23 kilopascal, which is much less than the vapor pressure at 20 degrees Celsius. Hence the water boils and form cavitation bubbles, and these cavitation bubbles, when they burst, release a huge energy which can damage the impellers. So you can see in pumps, at the suction side, the pressure will be very low. So here the pressure will be very low. Here you can see that cavitation bubbles form. And these bubbles, when they burst, can damage the impellers, just like we have seen in the earlier slide.